This is Module 4, Lesson 17, where we're going to do linear equation word problems. We're going to solve linear equation word problems, and we're going to write some equations from word problems. So let's get started reviewing a little bit about the linear equation just to make sure we remember it. Linear equation is y is equal to mx plus b, as you recall. It's written this way: y is equal to mx plus b. Now let's remember, our b is our y-intercept. Y-intercept means it's where the line crosses the y-axis. Here's our y-axis. Here's our x-axis. Where does the line cross the y-axis on this one? It crosses right here. And if this is the origin here, then this point is at 0, 1, 2, 3, 4, 0, 4. And our y-intercept is the b whenever we've got the point 0, b. So our y-intercept in this case is 4. Now, our m is our slope, our rate of change, okay? When we're talking a word problem, it's going to be our rate of change. Whenever we get it down to 1 unit, like miles per gallon, it can be called our unit rate, okay? Our slope can be measured by the change in y over the change in x, which is rise over run. In other words, how far we go up or down on the y-axis, our change in y, over how far we go left or right on the x-axis. And you know, if you go up on the y-axis, it's positive. If you go down, it's negative. Like a number line, if you go this way on the x-axis, it's positive. If you go this way on the x-axis, it's negative. Okay, so the slope on this particular line, I choose 2 points, and I use my rise over my run. I'm going on the y-axis. I'm going down 1, 2, 3, 4, down 4, and I'm going to the right 1, 2, 3, over 3. My slope is -4 over 3. That's my rise over my run, my change in y over my change in x, okay? So if my m is equal to -4/3, and I know it's negative because it's going down, all right? So if I were writing a linear equation from this, it would be y is equal to, my slope is -4/3. See how I'm putting that in place of my m? And my b is 4, okay? That's the way you would write that one. Now, let's now start looking at this and using this to model real-world scenarios, word problems, okay? In your workbook, go to page 216, and we're going to start with this one. This is just going to step us through seeing how you would write a linear equation for a real-world scenario and how it would compare to a chart if you were to graph it. A group of friends are on a road trip. So far, they've driven 120 miles. So they drove 120 miles and then they stopped, okay? Think about it like this. They're on a road trip. Here's where they started. They went 120 miles and then they stopped, okay? They continue their trip and they drive at a rate of 50 miles per hour. So now we're going 50 miles per hour. Okay, we don't know how many miles we're going, but we know we're going at 50 miles per hour, right? Okay. That's a constant rate. When we say constant rate, that means you've got a linear equation. It means your slope does not change. Now, let y represent the total distance traveled. So y is in what? Miles. In x hours. So x is the number of hours. Write an equation to represent the total number of miles driven in x hours. This is a linear equation because it has a constant rate. Y is equal to mx plus b. So start with our version of a linear equation. It's a slope-intercept form of it. Start with that. And we keep our x and the y because they're our variables. And we're going to plug in the m and the b. Now remember, the b is our starting point. Remember, we drove 120 miles before we stopped and started this 50-mile-per-hour thing. So our starting point is 120 miles into our trip. What is our M? Our rate of change is 50 miles per hour. Our M is 50. So we're going to put in 50 here. And now we've got, there's our equation. Y is equal to 50x plus 120. Okay? Remember, 50 is miles per hour. X is the number of hours. So if you wanted to figure out how many miles you've gone in any given time, let's say you were talking about 1 hour. If I'm going 50 miles per hour, I'd say 50 times 1, which is 50, plus 120. That'd be 170 miles, wouldn't it? What if I'd been going for 2 hours? Wouldn't I plug 2 in for this number of hours? 50 times 2 would be 100, plus 120 would be 220, right? And you can do that to figure out how far you'd gone after each number of hours, couldn't you? Okay, from this equation, they want us to identify the slope and the y-intercept. Well, the slope was the rate of change, 50 miles per hour. Okay, it says, what do these numbers represent? This is 50 miles per hour. This is the speed that we're going at, isn't it? This is how far we're going in 1 hour. What's the y-intercept? So this is our slope. Let's get our y-intercept, which is our b. That's our starting point. Isn't that the 120? What does that represent? We're 120 miles into the trip before we get this started, right? We've already gone 120 miles. 120 miles is our starting point. Now this says, go ahead and graph the equation on a coordinate plane. We know how to graph when we've got a line like this. Y is equal to 50x plus 120. We know when we're graphing that we start with our b. This is our y is equal to mx plus b. We start at our b. B is our starting point. It's where we begin. B means begin. Okay, so now look. Our y is miles. Look, on our y-axis, this is the distance in miles. On our x-axis, this is the number of hours driven. Okay, what is our starting point? Where do we begin? We begin at the 120. So on this y-axis, this is where it crosses the y-axis. We start at 120. At that point is 0, 120, isn't it? That means at 0 time, 0 hours, we've gone 120 miles. Then our slope is 50. If our slope is 50, we need, when we're doing rise over run, or change in y over change in x, we know that we've got to have this over something. I'm going to rise 50. I'm going to go up 50, but how many am I going to go over? What can I divide 50 by and not change it? 1. So I'm going to rise 50 and run 1. Okay. Notice our y-axis down here is in ones. Okay. So we're going up 50 and over 1. These are in 20s, aren't they? 20, 40, 50, be right in here and go over 1. All right. Say this is we another 10, 10, 20, 30, 40, 50, and over 1. You could keep doing this up 50, 20, 40, 50, and over 1. Okay, there we got it. Now let's draw a line through here. Okay, there's our line. We've drawn a line to show our equation as a plot. We can either show our relationship as a linear equation, y is equal to 50x plus 120, or you can show it as a graph, can't you? It's the same thing, same information. In fact, if you wanted to try to look some of these up, look guys, you could either plug things in here to the equation, or we can look them up here. What if I ask you how far we go after 2 hours? I could go down here 2 hours and say, okay, let's go up here and read it off the chart. It'd be about 220 miles. Or I could say I've gone 2 hours, and that would be 50 times 2 plus 120. 100 plus 120 is 220, wouldn't it? Okay. So you can get the same answer either way. These are two different ways to represent the same data. This is how you model it with a linear equation. Next question says, could any other line represent this situation? For example, could a line through this point 120 with a slope of 75 represent the total distance for inch drive? Well, if I did it as a slope of 75, that'd be 75, our slope would be 75 over 1. That tells me we're going 75 hours each, 75 miles each hour. And that's not going to give me the same date. In fact, if you plot it, it'd be 20, 40, 60, 70, 75 over 1. That'd be about there. And then you go up another 75. If you drew a line like that, guys, it wouldn't be the same line, would it? It would go through here and it'd go up really much faster than the other one. So no, that wouldn't be the same line. It wouldn't give us the same relationship. Okay. What we have just seen is that we've learned how to model this relationship with a linear equation because it had a constant rate. And we have learned that if you can do the plot, you get the same information from a model and from the graph. Let's go to the next page and let's model some of these. We're going to write the linear equation that models some of these word problems. First off, problems that involve an initial starting value and a constant rate of change can be modeled using a linear equation written in the form y is equal to mx plus b. This is called our slope-intercept form. Now, our rate of change, what's another word for rate of change? It's called the slope, isn't it? And guys, it's usually written as an M. I don't know why, but it is. Our initial value is our Y-intercept, okay? And the Y-intercept in this equation is the B. I don't know why they call it the B, but that is. So here, let's write some linear equations for these. Let's model these using a linear equation. A computer repair shop charges a $25 fee in addition to $40 per hour. That per tells you this is our rate right there to service the computer. Write an equation to represent the total cost to service the computer. Identify your variables, okay? Because we have a constant rate, we can write a linear equation. Y is equal to mx plus b. Our b is our starting point. Where do we start? We start with $25. We're going to get charged $25 just by leaving the computer there, okay? Even if we leave the computer there, the guy goes, oh, you forgot to turn the on button on, you're getting charged $25, okay? Now, what do we pay in addition to that? We pay $40 per hour, right? So our rate of change, our slope, our M is 40. There's our equation. That is our linear equation that models this relationship. 4x plus 25. There's our linear equation. See, there's a 25's in place of the b, plus x is there, your m is 40, equals your y. This is our linear equation. Now, let's identify our variables. What does x stand for? Well, in this case, if we're talking about how much we get paid, or we're paying for this computer repair, if it's $40 per hour, wouldn't I multiply that by the number of hours to figure out how much I pay for my hourly stuff? X is my number of hours, okay? What would Y be, okay? It's how much we're going to pay. That's going to be dollars, isn't it? If you're not sure, take your rate of change, which is 40, okay? And that is $40 per hour, isn't it? That's what it says right there, $40 per hour. That is my slope, my rate of change, my change in Y over my change in X. If I'm looking at this, guys, my Y then has to be money. Isn't that what I said right here? My X on the bottom has to be hours. Okay? You can use this to decide what your variables actually stand for. Now, what is the rate of change? The rate of change here is $40 per hour, isn't it? What's your initial value? $25. That's what you're going to pay, even if they don't spend much time working on it. Independent variable and dependent variable. Which variable is dependent on the other? The total cost of this is dependent on the number of hours they spend fixing it, isn't it? Okay? So your dependent variable is your Y. Your independent variable is your X. Okay? Let's look at number 2. An online photo printing shop charges 10 cents per print in addition to $2.95 shipping charge. Write an equation to model the total cost for printing pictures. Identify your variables. My equation is Y is equal to MX plus B. Okay. We start with where we begin. What is my B? If we're talking about how much we're going to pay, the total cost, don't we start with the $2.95 shipping cost? And then I need to find my rate of change, my slope. This per tells me this is my rate of change, or it is a rate. 15 cents per print. 0.15x plus 2.95. Okay, here is my equation. This is what my model, my linear model for this. I've written my equation to model it. Now, they asked me what my variables were. What is my x? What is my y? What am I talking about? I'm talking about my total cost. So y is actually my cost, isn't it? That's in dollars. What is my x? If this is 15 cents per print, wouldn't x be the number of prints? If you're not sure, use your rate. That's $0.15 per print, okay? I know my unit rates. I know all my rates are changing y's over changing x's, rise over run, right? My y is in dollars, see? My x is the number of prints, okay? What's your rate of change? It was 15 cents per print. What's your initial value? That was $2.95. What is my independent variable? That's the x. That's what we're starting with. And the cost depends on how many prints we print, right? Mark bought a season ticket to a ski resort for $395. However, he must pay $25 to rent skis each time. Each is like per, guys, okay? Each time he goes skiing. Write an equation to model the total cost that Mark will pay for skiing this season. We start with the linear equation, y is equal to mx plus b, and we find the b and the m. B is where we begin. If we're talking about what he's going to pay, don't we start with his $395? That's what he pays as his membership fee. Then he pays $25 to rent the skis each time. So our rate is $25 each time times the number of times he goes, right? Wouldn't that give me the total cost? What is my x? Isn't x the number of times he goes skiing? Number of times he skis. What is y? Isn't that the total cost? That would be in dollars, wouldn't it? Okay. If you're not sure, guys, write your rate out. It's $25 each time, right? $25 per time. Okay. And you know this is changing y over changing x. That's what slope or rate of change is. My y is dollars. Okay, total cost in dollars. Okay. My x is times, number of times he skis. What was your rate of change? It was $25 per time, isn't it? What was your initial value? $395. That's what he paid for his membership. What's the independent variable? That's the X, because the amount he pays, your dependent variable, depends upon the number of times he goes skiing. And then 4, Jane bought a car with 23,000 miles on it. She determined that she typically drives 12,000 miles per year. Write an equation to show the number of miles on Jane's car after each year she drives it. Okay, so we've got a constant rate, 12,000 miles per year. Y is equal to mx plus b. We can use the linear equation to model this, right? Okay, our b. Where are we to start with? Where do we begin? Well, that car has 23,000 miles on it. So we start at 23,000 miles. Okay. Now, what is our rate? What's our rate of change? 12,000 miles per year. That per tells us this is a rate of change. 12,000 per year times the number of years, right? So X would be number of years. Y would be what? The total number of miles, right? If you're not sure, write out your thing. Let's see, 12,000 miles per year. Okay. Equals change in Y over change in X. Okay. Your change in Y is miles. Your Y is miles. Your X is years. Okay. What's the rate of change? 12,000 miles per year. What's your initial value? 23,000 miles. What is the independent variable? It is X. What's your dependent variable? It is Y. Y depends on X. Okay. Now let's go to the next page. We're now going to write our linear equations that model this situation, and we're going to use them to find data. A truck rental company charges $19.95 to rent a truck plus 24 cents per mile. Find the cost to rent a truck and drive 188 miles. Y is equal to mx plus b. Okay? So what are we starting with? Our starting point is $19.95. That's what they're going to charge us to rent the truck, even if I don't drive it off the lot. What is my rate? It's 24 cents per mile. So the M is 0.24. Okay. Now, I'm talking about driving at 188 miles, and I want to know the cost. Well, which of these would I plug this miles into, the X or the Y? First, let's think logically, okay? If it's 24 cents per mile, wouldn't I need to multiply that by the number of miles to figure out what it's going to cost me for driving it? Okay, so it makes sense 188 goes in for the X. If you're not sure, use your rate of change, 24 cents per mile. Okay, that's the change in Y over the change in X. Okay, now what we're looking at here is our Y is our dollars, our X is our miles. So we will plug this 188 in for the X. Y is equal to 0.24 times 188. And then I add 19.95 to that. Okay. Put that into your calculator. And I've got 24 cents times 188. That gives me $45.12 plus $19.95. That gives me a total of $65.07. Eva started a savings account with $500. If she plans to save $75 each month, find the total balance after 2 years, okay? Now, first, let's write our equation. Y is equal to mx plus b. Where does she start with? She starts with $500. She's saving $75 each month. Each tells me that there's our rate. So our M is 75. Okay? Now, Y is the total amount she's going to save, right? Okay, now they want to know how much she'll save in 2 years. Well, what is this rate in? $75 each month. These are years. Don't I need to convert this to months? There's 12 months per year times 2 years equals 24 months. We need to plug this in for the X. That's our months. Y is equal to $75 per month times 24 months plus 500. Okay? If you're not sure which one it goes in for, X or Y, use your rate. That's $75 per month. You know this is changing Y over changing X because it's our slope. Months is your X. Okay? In your calculator, 75 times 24. That's 1,800. Y is equal to 1,800 plus 500, which gives me $2,300. That would make sense if she started out with 500 and she saves $75 each month for 2 years. Number 7. At the beginning of Jack's diet, he was 257 pounds. See the word beginning? That's telling you that's your B, isn't it? If he lost 3 pounds per week, lost means he's going down. Find his weight after 12 weeks. Well, let's write our linear equation. Y is equal to mx plus b. What's our B? Where are we beginning? We're beginning at 257 pounds. Our slope is 3 pounds per week. We're going down 3 pounds per week. Okay? Now, we've got 12 weeks. All right? So, wouldn't X go in for this? If you're going down 3 pounds per week, you'd multiply that by 12. Negative 3 times 12 plus 257. Okay? This gives me Y is equal to negative 36 plus 257. Okay? And that would give you 221 pounds. Now, I want to make sure you understand something. Sometimes when it's written this way, Y is equal to negative 3X plus 257. Sometimes they will use commutative property of addition and swap these, and they'll say, you know, I'm starting at 257 pounds and I am going down by 3 pounds every week. Multiply that by your number of weeks. You can do it either way. Okay? And number 8, number 8, it costs $5 for a membership to Topgolf, then $35 per hour. There's your per, that's your rate. If Max paid $127.50 during his first trip, how many hours did he play? So let's write our linear equation. Y is equal to mx plus b. Where did we begin? $5. $35 per hour. Okay. Now, guys, Y is equal to $35 per hour times the number of hours plus this $5 membership, right? He paid $127.50 during his first trip. Does that go in for the X or the Y if I'm looking for the number of hours? Well, you could step back and say, if he's paying $35 per hour, isn't this where the hours would go? This is not where the money would go. We're talking about the total amount of money. It's $35 per hour times the number of hours plus 5. That would be your money. So you'd put your $127.50 in for the Y. If you're not sure, use your unit, use your rate, $35 per hour. Okay, $35 per hour. And we know this is changing Y over changing X. So the dollars is the Y. This tells me I need to put it in here. $127.50 goes in for Y equals 35X plus 5. We'll subtract 5 from both sides. You've got $122.50 is equal to 35X. Okay, let's do that. $122.50 is equal to 35X. What do we need to do here? We need to divide both sides by 35. And X would be equal to $122.50 divided by 35. That would be equal to 3.5. Okay, 3.5 hours. That would make sense if he's paying $35 per hour, right? And he has an additional $5 to pay. Okay. And then number 9, a hot air balloon at 1,400 feet descends. That means it goes down. The hot air balloon, and here's the ground, and it's going down. Okay. It's up at 1,400 feet, right? Okay, it's going down at a rate of 75 feet per minute. Per tells you that you have got a rate. Find the time it will take for it to reach the ground. Well, let's write our equation. Y is equal to mx plus b. Okay? Our b, a hot air balloon at 1,400 feet. That means that's where it starts. So our 1,400 goes in for our b. What is our rate? It descends at a rate of 75 feet per minute. That means it's going down 75 feet per minute, okay? This is another one of these that I could also write this way because I'm starting at 1,400 square feet, 1,400 feet. I'm going down 75 feet per minute times the number of minutes, right? You could write it either direction. You get the same answer. Now it says, find the time it will take for it to reach the ground. Okay, how high off the ground will it be when it hits the ground? It will be at 0 feet. So if this is my number of feet, which I know it is because if I've got 75 feet per minute, my change in Y over change in X tells me Y is feet. This is the number of feet off the ground. 0 feet is where I need it to be on the ground. This is how physics questions will be done. Y'all will understand that once you take physics someday. 0 is equal to negative 75x plus 1,400. I need the x, which is what? The number of minutes. Okay, so I'm going to subtract 1,400 from both sides. Negative 1,400 is equal to negative 75x. Now let's divide both sides by negative 75. X is negative 1,400 divided by negative 75. Is 18.7, 18.666, and that would round to 18.7. What are my units? Minutes. 18.7 minutes. Okay? Makes sense. You start at 1,400 feet, you're going down 75 feet a minute, 18.7 minutes. Okay? And we're going to skip 10. I don't like the way it's written. Okay. And we're going to stop right there, and this will be the first, on this one we have gone through how to write a linear equation, how to model a linear relationship using a linear equation, and how to use that linear equation to calculate values.